How about them Cowboys? We still them boys. All right. So today is December 1st, and it starts Don't Shave December, which is like No Shave November, but it's in December, right? So if you want to keep the beard going, go for it. You should have written down the second line, altitude and Orthocenter. So it looks like this, but we are moving on to the notes that look like this. So altitude and Orthocenter, let's read this and underline some stuff as we go. The altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. So let's go ahead and underline perpendicular. That means it's going to make a right angle, right? And it's from the vertex to the line containing the opposite side. Okay? So if you look at this triangle over here, so this triangle right here, from R to Q to S. Okay, this is the original triangle. Let's see if I can draw this. And then from here to here, that looks terrible. And then from R to S, not that bad. All right, that's the original triangle. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. We're going to explore that down here at the bottom. In QRS, altitude QY is inside. So check it out. I know QY is an altitude because it starts at the vertex and it goes straight through and makes a right angle. Okay? So it keeps going and going and going. So altitude goes through the vertex. All right, and then it says RX and SZ are not. So look at RX from R at this vertex. If I want it to make a right angle, it has to go straight down, and this is outside of the triangle. So sometimes your altitudes are outside the triangle to make a right angle. Also SZ, here's the vertex. To make a right angle, it goes straight down, and that makes a right angle. Now, they're all supposed to meet right here at P, and that point is called a orthocenter. So does everyone see that new word, that new center of a triangle today? It's called an orthocenter. All right, so look down here at the bottom. We're not going to turn and talk, but we are going to do this. Based on the definition of an altitude, draw all the altitudes of the triangles. Okay. So what kind of triangle is this one right here? Acute, right? What about this one right here? B is bigger than 90, right? So that's going to be obtuse. And you can tell on the next one, it's going to be right. So 3 different types of triangles. Right. So let's make these altitudes. Now we're going to do a rough sketch of these. But if I start at angle A and go straight down, something like that. If I go from angle B towards AC to make a right angle, it'll look something like that. And then from angle C towards AB would go through that intersection point and make a right angle. So I've got a point of concurrency. All right. And let's answer the question right below that. The orthocenter of an acute triangle is inside the triangle, right? Does everyone see? I'll do it in red that the orthocenter is inside. 3 altitudes, and it's inside. But the one that's different is obtuse, okay? So obtuse, I'm going to pick vertex A. If I try to make a right angle, it has to go straight down, right? So I need to extend this line. Extend, 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 extend. Okay? And I'm going to make a straight line go through, okay, straight down. And you can use your protractors for this. And that's a right angle. All right? And then I'm going to do the same thing using point vertex C right here. It needs to go perpendicular to this extended line. So So I'm going to draw it using my protractor. It needs to make a right angle. Okay, so it's going to be something like this, as long as it makes a right angle. And then using vertex B, it's going to need to go and be perpendicular to AC. So about right here. And you can see that's also perpendicular right there. Okay, so 3 perpendicular lines all intersect right about here, and that is my orthocenter. All right, so how are we going to answer the bottom? It's going to be on the outside. Does everyone see that that point is outside of the triangle? Right there. I'll do it in red so you can see it. All right, and then right triangle. So again, from point A down to BC, to make a right angle, it's actually going to go along the edge. Okay, so when I see a right angle, I know it's going to go straight down. Same thing with point C. To go towards AB, I already see a right angle is going to go along the edge. And then last but not least, from point B to AC, to make a right angle there, it's going to go inside. But I want you to see edge, altitude, edge, they all intersect at point B, which is on the triangle. Okay? So let's make a few little rules here. Obtuse, orthocenter is outside. So there's your O rule. If you're doing the obtuse triangles, orthocenter, it's going to be outside. O, O, O. True. And for a right triangle is going to be right on the vertex of the right angle. So I'm telling you, anytime they say, what's the orthocenter on a right triangle, it's always on that vertex. And if they ask you, where's the obtuse triangle's orthocenter, it's going to be outside. Acute is inside. All right, so let's flip it over and try some of these using the grids. Okay? So, you still copying that down? All right, sorry. Here we go. Make sure you get this down. And when you get that, you can flip it over. All right, so flip it over, and on the back, we are talking about practice problems given a grid. Now, you need to know how to do this to do yesterday's assignment on the back, right? Sorry, so this says to find the orthocenter of triangle JKL. So everybody, let's plot JKL. J, -4, 2, put a point there, call it J. K, -2, 6, put a point there, call it K. L is at 2, 2, put an L there, okay? And then we're going to connect these with straight lines. So I'm going to use my straight lines now. All right, so I have my triangle, and you should have it too, using your straight edge, your compass, your protractor to do. So the process to find an orthocenter, the way you get your 3 altitudes is, first of all, I need to find the 3 slopes of all 3 sides. So we're going to make a little chart here. Let's find the slopes of JK, and I'm not kidding. Thank you. KL and JL. Okay, so let's find these 3 slopes, because I'm going to need to find a perpendicular slope. And if you remember, we did this before. That's the opposite reciprocal. Okay, so for JK, what's the rise over run for JK? 1, 2, 3, 4, 1, 2. So JK is 4 over 2, and that reduces to 2 over 1. Let's look at KL. From K to L goes down 4 and right 4. That means negative 4 over 4, which is negative 1 over 1. And then JL is totally horizontal. That means that's going to be a 0 slope. Okay? Now, those are my 3 slopes. What I need to do now is find the perpendicular slope. Okay? And if you don't remember what perpendicular means, it's going to be the opposite reciprocal, which means opposite changes the positive / negative sign, and reciprocal means we flip it, right? So this is old news. So what's the opposite reciprocal of 2 over 1? Negative 1 over 2. I change the sign, I flip the fraction. What's the opposite reciprocal of negative 1 over 1? 1 over 1. The negative turns to positive, right? And if you didn't know this, that's fine, but the opposite reciprocal of 0 is undefined. It's going to be a vertical line. So undefined and 0 are opposites. So now here's what we're going to do. I'm going to use this perpendicular slope at the missing vertex. So JK, what's the other vertex besides JK? L. So for KL, what's the missing vertex? J. And for JL, the missing vertex is K. So all you got to do now is make lines with this slope at this point. And I'm going to show you how it's done. This is how we do it. So, starting at L, I'm going to go down 1, right 2, or up 1, left 2. We'll do that way. So, oops, hold on. So I'm going to put points there first. So up 1, left 2, up 1, left 2. And I'm going to make a straight line go through that. There's my altitude. Do you see that right angle through a vertex? It may not be perfect, but that's how you do it. Right angle. And then starting at J, I'm going to go up 1 over 1. So J, up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to make my altitude. And you can see that one's also a right angle. Put a little right angle sign. And then, last but not least, starting at K, it's undefined, so I go straight up and down. And you can see it's going to go through, all through the same exact point. Now, is that kind of hard to see? So we zoomed in so we can actually see it. And do you see where the orthocenter is? Right there, right? Those 3 altitudes cross at -2, 4, right? So my orthocenter is at -2, 4. And you can box that in, right? So let's do the next one real quick. So moving down to number 2, we're going to plot these 3 points real quick and connect them to make a triangle. And then we're going to write down all 3 sides and their slopes, as well as the perpendicular slopes off to the right. We draw all of our altitudes, and we get our orthocenter. So that's the whole thing done. I know that was really quick, but it's the same process as number 1 there on number 2. And doing that will help you do the backside of the assignment you got yesterday, the one that was on medians. This on the backside has to do with altitudes and orthocenters. Okay, so we can do a zoomed in version of this just in case you need to see it up close. And so there it is. You can see at 4, -1. So make sure you wrote the answer down here. Box it in. And that's the notes for orthocenter and altitude.